IT Strategy Overview. The IT strategy for transmit is split into two sections as shown in internal and overall. The internal is responsibility of the transmit partners participating to the transmit is via service. The overall is defined by the developers of the prototype presentation layer. It is beyond the scope of this article to expand further on the overall IT strategy, however SOA, service-oriented architecture, is briefly recalled as one of the best practices that are used within the IT strategy and is known to generate real business value. Moreover, SOA supports the so-called workflow systems, WSs, which allows for building of software applications from a number of loosely coupled, heterogeneous, distributed services. Which is the case of transmit is needs. SOA represents a paradigm shift in applications design, which includes decomposing business functions and application features into a set of independent but cooperative subsystems or services. This helps businesses to gain flexibility, reuse, and interoperability, which in turn implies reduction of operational costs, acceleration of the development of new application by leveraging shared service capabilities, minimization of operating errors and reduction of risks and disruptions to business. Finally, SOA can demonstrate business value and at the same time assess/fine-tune performance and model/modify processes through key performance indicators, KPIs. No matter what the overall IT is going to be, SOA philosophy can be still applied for the development of various data services within the data layer. However, it should be stressed that the development of the presentation and business layers dictated by the overall IT strategy, influences the development of the data system which will realize the data layer, since it can pose unique requirements on the data system or require the design of new data services. Results? The strategy adopted for data management in the frame of transmit is broad in scope to allow flexibility given the evolutionary prototyping development methodology of the transmit is, C. Such choice will also benefit the IPDM prototype development by providing the capacity to the data layer to accommodate further business and application layers needs in terms of data management services. We begin this section by discussing the data and information needs of the transmit is which capture the state of the IPDM prototype at the time of writing of this article. These needs should be frequently reevaluated and the data strategy should be kept up to date. The initial survey conducted shows that the prototype system relies on a variety of proprietary data files in ASCII and binary format, originating mainly from GPS and radio occultation satellites as well as other spaceborne instruments. The input and output products have either spatial, for example global tech maps, or temporal dimensions, for example complex GPS RF data, or in some cases both, global tech maps, predicted over time. Regarding the complex GPS data per se, the size of data files can generate a huge bottleneck, if data movement is scheduled during the operation of the distributed system. Finally, outputs from theoretical models, implemented in different programming languages, have to be also provided, such as the ionospheric models IRI and NIQUIC2, just to name a few. Based on the above needs we have developed a general data management strategy that includes, among the others, a compelling vision for DM. The mission and long-term directional goals of DM. Strategy statement. Short-term SMART, specific measurable actionable realistic time-bound, DM objectives. The transmit DM vision and mission is to realize an intelligent DM system that will offer benefits to the enterprise and its customers and leverage existing IT/DM activities. The main mission of the DM function is to meet and exceed the data/information needs of all stakeholders in terms of data/information availability, security and quality. To pursue our vision and fulfill our mission, our strategy is to establish the following data management initiatives. Data architecture, DA, function. Data development, DD, function. Data operations, DO, function. Content management, CM, function. Metadata management, MDM, function. Data security management, DSM, function. Data quality management, DQM, function. Finally, the short-term SMART DM objectives are listed below for each of the above-mentioned function. Data architecture, DA, objectives. Define the data model. Analyze and align with business models. Define data technology architecture. Define metadata architecture. Data development, DD, objectives. Analyze information requirements. Develop conceptual, logical and physical data models. Design physical databases. Design information products. Design access services. Implement development/test database changes. Create test data. Migrate and convert data. Build and test information products. Build and test data access services. Validate information requirements. Prepare for data deployment. Data operations, do, objectives. Implement and control database environments. Obtain externally sourced data. Plan for data recovery. Backup and recover data. Set database performance service levels. Monitor and tune database performance. Plan for data retention. Archive, retain and purge data. Support specialized databases. Content management, CM, objectives. Implement management systems for acquisition, storage, access and security controls of unstructured data. Backup and dispose unstructured data. Retain and dispose unstructured data. Data security management, DSM, objectives. Understand data security needs and regulatory requirements. Define data security policy. Define data security standards, controls and procedures. Manage users, passwords and group memberships. Manage data access views and permissions. Monitor user authentication and access behavior. Metadata management, MDM, objectives. Implement a managed metadata environment. Create and maintain metadata. Integrate metadata. Manage metadata repositories. Distribute and deliver metadata. Query metadata. Data quality management, DQM, objectives. Define data quality requirements. Define data quality metrics. Define data quality business rules. Test and validate data quality requirements. Set and evaluate data quality service levels. Design, implement and monitor operational data quality procedures.